Hello students, welcome to online maths classroom. This is part 2 of your topic integration, and in this video we'll learn about method of substitution and how to apply the method of substitution in exercise 7.2. So let us start with it. Methods of integration. Now, in previous section, we discussed integrals of those functions which are readily obtainable from derivatives of some functions, means where we can apply the direct formula. Okay, it was based on inspection, that is on search of a function f whose derivative is f, which led us to the integral of f. However, this method which depends on inspection, it is not very suitable for many functions. Okay, so we have to develop some additional technique, and out of which the prominent methods are your integration by substitution, your integration using partial fractions, and number 3 is integration by parts. So let us start with integration by substitution. Okay, in this method we consider the given integral fx dx, okay, and it can be transformed into another form by changing the independent variable x to t, okay, by the suitable substitution x equal to g of t, right? Means if I do substitution in such questions, then my question can be integrated easily. Okay, so say I is equal to integral fx dx is the function. So if I'll put x is as gt, so dx upon dt will be your g dash t, okay, and dx will be g dash t dt, right? And therefore I can change integral fx dx to your f of this. In place of x I'll put gt, and my dx will be changed to g dash t dt, okay, and then I can integrate it easily. So this is method of substitution. So let us start with. Now let us discuss some important integrals which involve your trigonometric functions and their standard integrals using this substitution technique. So the very first one is your tan x, integral tan x dx. You know, when we integrated our secant square x, the direct formula gave the integration as tan x, depending upon the property of antiderivatives, right? And we have done in the previous video, you have learned that tan square x can be integrated by breaking it in the form of secant square x minus 1, right? But how to integrate tan x? So to integrate tan x, I must use this method of substitution. Okay, and this is a formula to be remembered, right? So to integrate tan x, what I need to do is I need to change it in the form of sin x upon cos x, okay, and then I'll put my denominator as t, cos x as t. Why? Because its derivative sin x dx is present in the numerator. Now when I'll put cos x equal to t, so differentiating both sides, I'll get sin x, okay, and it will become my dx, sin x dx is equal to minus dt, okay, means because the derivative of cos is minus sin x, okay, the derivative of cos is minus sin x, okay, and it is dx upon dt is equal to ddt of t is 1, right? So in that case it becomes your sin x dx equal to minus dt. Why I'm taking sin to other side? Because here my function is sin x, okay, so I should be very careful about the signs. So now the function changes to this sin x dx can be written as minus dt upon t. Now this has become a function like your, say, 1 upon x dx. So you know how to integrate your 1 upon x dx? It is as log mod x, okay. So it also becomes, it doesn't make any difference whether it is t, because this function is in terms of t, and if it is dx upon x, so it will be in terms of your x. So the integral is same, and it will be your minus log mod t plus c, okay. So replace the value of your t, it will be minus log cos x plus c. So this is this integral is means a root, you can take integral tan x as minus log mod cos x, or one other form is there where you can change it to secant form. Now how to change it to secant form? Can I write it as, say, minus log of say 1 upon secant x, Why? Because my and plus c. Because my cos x is 1 upon secant. Now open the property of log. Like what is your log of? It becomes log of a upon b is log a minus log b. Okay. So it becomes log 1 minus your this secant x, and this minus sign is outside. Now what is log 1? Log 1 is your 0. Okay. And this minus will merge to give me plus log secant x plus c. So you can put the integral tan x by the both values like log mod secant x or minus log mod cos x, and we use as per the need of our question. Okay. So in general, maximum times minus log mod cos x is taken into consideration. Now similarly for integral cos x, I will write it as cos x upon sin x dx. Okay. Now put this sin x as t. Right? Why? Because derivative cos x dx is present in the numerator, and it also becomes integral dt by t, and which is your log mod t plus c, and t is your sin x. So it is log mod sin x plus. Similarly, secant x. So you have to learn these two because there is a method of integrating this. You have done integral of secant square x. Okay, but you have not done the integral of secant x. So integral of secant x can be calculated by this method. You have to multiply and divide by secant x plus tan x, right? Similarly, for this cosecant x, you have to multiply and divide by cosecant x plus cot x, right? Now, what then we do? Again, we will put this your denominator equal to t. See, again here also denominator equal to t, right? Now, what is the derivative of secant x? It is secant x tan x, right? Derivative of secant x is secant x tan x, right? And what is the derivative of tan x? It is secant square x. So can I take secant x common? Okay. So means after opening it, you will get the same, and dx is equal to dt, right? So see that it is, this question is also represented as dt upon t, which is again log mod t plus c, and your t is secant x plus tan x. So it is log mod secant x plus tan x, okay, plus c. Similarly here, the derivative of cosecant x is minus cosecant x cot x. Okay, and the derivative of cot x is minus cosecant square x. So see here, I have taken minus cosecant x common. So it is same minus cosecant square x, and it is minus cosecant x cot x. So take minus cosecant x common, right? Why? So that I can put my this cosecant x into cosecant x plus cot x as minus dt. Okay, take this negative sign to this side. So it becomes minus dt upon t. It is minus log mod t, which is your minus log mod cosecant x plus cot x plus c. Okay. Now see from here. Now this is there lies one important observation which you need to understand. Right? See what is happening here. That can I divide means can I write my this minus log mod cosecant x plus cot x, right? What we did, we rationalized it. Okay, we multiplied and divided by cosecant x minus cot x. So what happens to the numerator? Numerator becomes like a plus b into a minus b, that is cosecant square x minus cot square x, which is your 1. Okay, so this becomes your minus log of 1 upon cosecant x, okay, minus cot x. Why? Because we multiplied and divided by our cosecant x minus cot x, okay, plus c, right? Okay, so what happened? That again I will open it as minus times log 1 minus log of this complete thing. Log 1 is 0, and it will make minus and minus as log cosecant x minus cot x mod plus c. Okay, now take some examples. Example number 6 is find the following integrals: sin cube x, cos square x. Okay, now substitution. How to do the substitution? Substitution you will do in this manner, right? So that its derivative is present there, right? Okay, so and it is easily reducible also. Like see, it is of the form sin cube x cos square x, right? So here what will I do is that I will take, as you see, sines, I'll take sin square x here, 1 cos square, okay, and take 1 sin x roof, right? Now what can I do? I say 1 sin x is a roof. So you can open sine square and cos square, but you cannot open sine, because then under root term will be developed. So sin x, whose derivative is sin x? It's the derivative of cos x, right? So I'll change my complete question to cos. This cos square is cos square, and I'll change sin square to 1 minus cos square. This is cos square and this is sin x dx. And then put cos x equal to t. See what happens. Okay, your dt is equal to minus sin x dx, right? So what happens, it is minus times, this is your sin square x, this becomes 1 minus t square. Okay, this is your t square, and this sin x dx will become minus dt, whose minus I have taken outside. Now open it, it becomes minus times t square minus t4 dt, and you know t square integral is t cube by 3. This is minus t5 by 5 plus c, and put the value of t, who was your cos x, and you will get the answer. Second question is very, very important. Very important. Please observe it carefully. Integral sin x upon sin x plus c. Means the basic thing is the need to understand what is to be substituted. Okay. Now see, some question is like sin upon sin x plus a. What can you do about this sin x plus a in the denominator? If you are means thinking of opening it, means you are getting a denominator which is very heavy, right? You cannot do anything. So let us twist the question and make the numerator heavy so that I can split the terms. So for it, what will I do? I'll put this x plus c. This is my problem actually. It as t. So dx equal to dt. Why? Because this derivative of your a is equal to 0. Okay. So it becomes, as see from here, x plus a is t. So x is t minus a. So it becomes sin t minus a upon sin t dt. Now open by the formula sin a minus b. It is sin a cos b minus cos a sin b. And it is sin t. Now what happened? That the numerator has become heavier. Now I can split, means separate the terms. It is sin t upon cos a upon sin t. So sin t will cancel, and I'll just get cos a times 1 dt. And it is your cos t sin a upon sin t. So cos upon sin is your cot, and sin a, because a is not having, means it is not a function of t, so it's treated as constant. So that's why cos a and sin a are outside the integral. So what is the integral of 1? It is t. So it is t cos a. Integral of your cot, we did it right now, is log mod sin. Okay, log mod sin t plus c, c1. Okay, plus c1, constant c or c1, whatever you want to use. Now put back the value of t, that is x plus a. Again, wherever this was there, you put back all the values, right? And open the terms. So the sin a will be multiplied with the c1 also, which ultimately is a constant, because sin is a constant and c1 times sin a is also constant, right? So this is your integral, right? And what we can do is means this a cos a and minus c1 sin a, they can be taken as some one common constant, because they are constant, no variable term is there. So you can express the answer like this. Okay. Next is your dx upon 1 plus tan x. Okay. See, there are 4 types of question like this. One is your, you will get in your exercise like this is dx upon 1 plus tan x. Same question can be 1 minus tan x. Okay. 1 minus tan x. Same question be in the form of 1 upon 1 plus cot x. Okay. Or 1 minus cot x. Okay. So means there are 4 questions. So just understand how to do. Just understand, right? There are 4 questions, not one. I'm discussing one, but you will find one of them in the exercise, and they are actually 4 questions to be done with the same pattern. So first thing is open in sin cos. Take LCM. It is 1 plus sin x upon cos x. Take LCM and you will get it like this. And this becomes your cos x like this. Okay. Now what is there? That this is again the denominator is heavier. So I'll multiply and divide by 2. Okay. Half into half. So it is 2 cos x. Right. So 2 cos x can be written as cos x and cos x. Cos x plus cos x. See this. Right. Now to make the derivative of this denominator in the numerator, what can I do is, now I am helpless. Still I am helpless. Right. So should I do? I will add and subtract sin x. Okay, and make this cos x plus sin x one pair and cos x minus sin x as other pair, and then open, break the numerator now. So cos x plus sin x upon cos x plus sin x is your half outside 1 dx, and it is plus half cos x minus sin x upon cos x plus sin x, right? We have splitted the numerator. Now integral of 1 is x, so it becomes x by 2, right? And its constant is c1 by 2. You can put the constants at last also. It's not mandatory that you should write the constant here. Okay, you can altogether mention the constant here after completing integration, that is c. That is also okay, right? Plus half of this. Now again see, the derivative of this term is this, c from here. So I'll put this as t. It is actually the form f dash x upon fx. We will discuss about it. The form f dash x upon fx. Okay. So just learn substitution, whose integral is given by your log of mod fx. Okay. Fx plus c. Log mod fx plus c. Okay. So see, I have substituted cos x plus sin x as t. So the derivative of cos is minus sin c from here, and sin is cos. After arrangement is cos x minus sin x dx equal to dt. So it becomes again dt by t, which is log mod t plus c2, the constant for this integral, and put back the value of t, that is log of mod cos x plus sin x plus c2. Okay. Now you have to arrange all of them together, and these two constant terms to be taken together to give an ultimate constant c. So it's not necessary that you should put integrals everywhere. You can put the integral directly, means constant after here also. So this is the required answer. Now let's come to the exercise and think of the suitable substitutions. So first is integrate the functions in here. Now see, as it is 7.2, so you know that it is the using method of substitution. But if it is an open question in examination, how will you come to know that this question cannot be done by simple method and you have to follow substitution? Now start observing. 2x upon 1 plus x square. You can see breaking of numerator is not desired. Okay, it is not possible here. You cannot put any direct formula. But see, if 1 plus x square is substituted as t, the derivative of x square is 2x dx equal to dt. See, okay, this is how we means with respect to x we are differentiating, so it is 0 and it is 2x equal to dt by dx. Okay, and then cross multiply means x variable to one side, t towards the other side, right? So what is happening means I should be able to judge that see, the derivative of denominator is present in the numerator, right? If the direct integration is not possible, then think of the substitution. Okay, substitution. So see, it becomes your and this dt by t again. See, why 2x dx dt is your dt, so it is dt by t, which is, you know, it is log mod t plus c, right? Now put back the value of log mod t, means 1 plus x square plus c, and this is your desired answer. Okay, right? Now see here. Now see, it is not always that the denominators are only substituted. Substitution is to that whose derivative is present alongside or near to it, either in the numerator or in the denominator. So in this question, I'll put log x as t. Why? Because its derivative is 1 by x. Okay, 1 by x dt by dx, that is 1 by x dx equal to dt. Now see, this dx by dt, this is your dt. Okay, and this is t, so it becomes t square. So this way also the substitution can be twisted. Okay, look for the derivative in any format. So it becomes t cube by 3 plus c. Now put back t as log x, and this is the answer. See number 3, 1 upon x plus x log x. Now firstly, you don't think of rationalizing it or doing anything else. You know, this is a question where you have to apply your mind to take x common in the denominator. And now put this 1 plus log x equal to t. Right? Now you will ask that how you will develop this sense that what should be substituted. Right? So see, First method is of direct integration. If it is not possible, the second thing is do some rearrangement, okay, and search for the derivatives. So see, what can I do is I can take x common, and as soon as I take x common, this 1 plus log x is to be searched for the derivative. And you know, 1 is derivative 0 and it is 1 upon x. So my purpose is solved. So that means this 1 upon x dx, this is dt. So it becomes your dt by t again. See, so it is log mod t, and put back the value of t as log of 1 plus log x mod plus c. Okay. Now number 4. See here, sin x sin cos x. Now this sin is whose derivative? It is the derivative of your cos x, right? Because I cannot separate this, so put cos x equal to t. It becomes minus sin x dx equal to dt, right? That is, this becomes, okay. Now put back the value, okay. But what does it become? It becomes your minus. So it is your substituting cos x, so it becomes sin t, and this sin x dx will make the pair here, and it will become minus dt. So it becomes minus sin t dt. What is the integral of sin t? It is minus cos. So minus cos is cos t plus c, and it is cos of cos x plus c. Number 5 is sine. Whenever sine and cos are together, see, and both are having same power, you can put any one of them, right? It is your desire. You can put any one of them as t. That is the one method. Other is, as both are having the same angles, means thetas also. So by multiplying and dividing by 2, you can make it as 2 sin theta cos theta is sin 2 theta, right? So it can be written as sine of 2 times this ax plus b, right? Now it is half of, what is the integral of this sine? Sine is your minus cos of this, okay, and divided by the derivative of this 2ax plus b. So the derivative of 2ax is your 2a, okay, which is your 2a, right? So it becomes 1 upon 2 into 2a, that is 1 minus 1 upon 4a cos 2 times ax plus b plus c. Other ways, you put either sin x equal to t or cos x equal to t. But it is suggested, as you know, that the derivative of sin x will be cos x. So it's better to put sin ax plus b as t, right? So that is also the one method. Number 6 is root ax plus b. Now see, it has nothing to do with the substitution. No doubt this question is present in this exercise. This is the sense the student you need to develop is, it is not that it is present somewhere. Your mind should be applicable, it should be such applicable to work that see, it is a power rule can be directly applied. So I should go for power rule. There is no need to go for substitution. So it is your ax plus b raised to power 3 by 2 by 3 by 2 and divide by t dx of ax plus b, that is a. Let's see, this is the desired answer. X into root x plus 2 again, right? This is your, you see, it is actually linear root linear, right? I'll give you formula for this also. See, we will be discussing here. So these are two methods out of which the suitable one you can search. Okay. So first way is you have to, means you know that whenever we were there, like if it would have been means say root x into x plus 2, so what would I have done? I have taken this root x inside, right? So here I cannot take, so what will I do? I'll try to make this x as x plus 2. So how it can be done? By adding and subtracting 2, right? Now multiply this term and this term. It becomes x plus 2 raised to power 3 by 2, and it becomes minus 2 x plus raised to power 2 raised to power half. Now apply your rule, that is this power 3 by 2 plus 1 upon 3 by 2 plus 1, and d dx of x plus 2 is 1, so divide by 1. Minus 2 times x plus 2 raised to power half plus 1 upon half plus 1 into d dx of x plus 2 is 1, and plus c. Now rearrange all the powers, okay? take to the numerator and it is done. Okay, but I would suggest that better is to learn a format, how to treat linear under root linear. Okay, whatsoever the question is, put this linear inside the root as t. Linear inside the root as t. Okay, root x plus 2 is t. Squaring, what will you get? X plus 2 is t square, or x is your t square minus 2. Now change the complete question to your t. So x is t square minus 2. So I should also differentiate also, because I have to change dx also. So it becomes dx is equal to 2t. Okay, dx is equal to 2t dt, right? So dx by dt means it becomes dx equal to 2t dt, right? So you can differentiate by with respect to t both sides. So how my question changes? It automatically changes to t square minus 2 into t into dx is 2t dt. Means the whole question changes to, you have this 2t raised to power 4 minus 4t square, and which can be integrated using power rule. Okay, so 2t raised to power 5 by 5 minus 4t cube by 3 plus c. Now put back your t as root x plus 2, and then you can get your answer. Okay, so I think you should develop this skill. This will serve you, but you should know this also, right? Means this is also a very good method. Then is number 8, ax times root 1 plus 2x square. Now again come back to substitution. Okay, come back to substitution. Lot many ways are there, but my dear students, you must understand, better is, this is actually linear, see, linear root quadratic. Okay, x into root 1 plus 2x square. This is your question, right? See, the derivative of this 1 plus 2x square is your 4x. So I am having x, so that means I can divide and multiply by 4. That is no problem, right? So means the constant numbers can be multiplied and divided. So I'll multiply and divide by 4. So that my purpose is served. And now I'll put my 1 plus 2x square equal to t, and 4x means 4x with respect to x we are differentiating. So 4x equal to dt by dx, that is 4x dx equal to dt. So my question changes to 1 by 4 times root t, and this is your dt. See from here. See from here. Okay. So this becomes 1 by 4 t raised to power, and which can be treated as t raised to power 3 by 2 by 3 by 2 plus c. Okay, rearrange, put back your t as 1 plus 2x square, and you can get the answer. Okay, and also if it is your linear under root quadratic, then also the quadratic inside this is substituted as t, or means this quadratic term is substituted as t. So we'll talk about that method later, but this is also one way of treating it. Okay, means simple substitution says you should search for the derivatives. Number 9, right? Number 9 is, see from here. The derivative of x square plus x plus 1 is 2x plus 1, right? So if you take 2 common from here, you'll get 2x plus 1. See, so my purpose is solved, right? So that means my x square plus x plus 1 is t. So 2x plus 1 equal to dx equal to dt. So that means it will become your integral will become, this 2 will be there. This is your root t, and this this dx along with this term will give you dt. So it becomes 2t raised to power half, which can be integrated by using power rule as 3 by 2 upon 3 by 2 plus c. Now put back the value of your t, and this is the desired answer. 1 upon x minus root x. Okay, so here also what will I do is that I'll put linear inside the root as t. That means my root x as t, right? You can think of this question like this also. Can I write this question as 1 upon root x upon root x minus 1. Open it, see. This root is on this x only. So it becomes x minus root x. See, this is also one way, right? This is also one way. So it's that you put root x equal to t. So x is t square. See, dx is 2t dt, and this question changes to 1 upon t square minus 1 2t dt. So it is 2 t upon t into t minus 1, right? So it becomes your, this t and t cancels. So 2 upon t minus 1, that is 2 outside t minus 1. Now I have told you what is 1 upon a linear. Whether it is 1 upon x or 1 upon any linear function power, it is always log mod of that function divided by the d dx of ax plus b, that is a. So what is the integral of your this 1 upon t minus 1? It is 2. It is your log mod t minus 1, and the derivative of t minus 1 is 1. So divided by it will give you just 1. Now put the value of t as your root x and you will get this answer. Okay, right? And the second way is you can put this root x minus 1 as t. Okay. Then comes number 11. Number 11 is actually, it is also of the form of linear under root linear. Okay, right? So first thing is, either you make the denominator in the numerator by adding plus and minus 4. So it becomes, means separate them, x plus 4 upon root x plus 4 minus 4 upon root x plus 4. This becomes like x raised to power 1 upon x half is 1 minus half, that is root x plus 4, and it is your minus 4 upon. Now you know what to do. See, this is the process which is explained here. Okay, now 1 means you have to take it as your negative power to the numerator, and then apply power rule. Okay, power rule, and then put back your the value of the function t, and this is the required answer. Second method, the very important, means how you should remember linear upon and root linear, is put the root linear as t. Root x plus 4 as t. X plus 4 is t square. X is t square minus 4. Dx is 2t. Okay. Changes to t square minus 4 upon t into 2t dt. Right. So it becomes 2 times t square minus 4 dt. Right. So open it. This question changes to this form, which you can integrate. Okay. Means you can just re-put the value and just, it is t cube by 3 minus 4t, right? And take your t common and put back t as root x plus 4, and this is the desired answer, right? So this is also one way. Number 12 is, you cannot take x raised to power 5 inside. See, how will you take? This is 1/3 power. So what will I do? Now search, what is the derivative of this problem? X cube minus 1. It is 3x square. So x raised to power 5 is there, so it is having x square. So break it as x cube into x square dx, because these both I require for my dt. Okay, and the only thing is that because I cannot operate this 1/3 root, so put this x cube minus 1 as t. Right? So therefore x cube becomes t plus 1, and I'm going to change whole of the question in t form. See, so if x cube minus 1 is t, so it becomes 3x square is dt by dx, or 3x square dx equal to dt. So see what is happening. It is 1 by 3. This becomes t raised to power 1 by 3. Okay. This x cube becomes t plus 1, and 3x square dx becomes dt. And see, by opening inside, whole question changes to t. T raised to power 4 by 3 plus t raised to power 1 by 3. So use the power rule, plus 1 upon 7 by 3 plus 1. And this is 1 by 3 plus 1 upon 1 by 3 plus 1. Okay. Now change t as x cube minus 1, and you will get the answer. Again, 1 upon x log x raised to power m. So it is very clear that put log x is t. Okay. Put log x as t, because log x is having 1 upon x, as we did a question earlier also. So put it like this. And because I can write it as 1 upon x dx upon this. So 1 upon x dx equal to dt. If either you are not writing, then also it is okay that you know that both of them all together will bring dt. So this question changes to dt upon t raised to power m, and you know t raised to power m means it should be taken as t raised to power minus m. Okay, then add and subtract means use power rule, t raised to power m minus 1 upon minus m plus 1. Okay, minus m plus 1 upon minus m plus 1 plus c, and put t as log x, and this is the desired answer. Don't forget to resubstitute what you substitute. Okay. Number 15 is x upon 9 minus 4x square. So search for what is the ddx of 9 minus 4x square. It is minus 8x. So x is there, and from with 8 you can multiply and divide. See, with minus 8 also you can multiply and divide. And now put 9 minus 4x square equal to t, minus 8x dt by dx, minus 8x dx equal to dt. The question changes to minus 1 by 8 times 1 upon t, that is log mod t plus c. Put back the value of this t, and this is the answer. Right? Now what is the integral of e raised to power something? It is your e raised to power x. Okay, e raised to power x. But don't forget to divide by the derivative of 2x plus 3. What is the derivative of 2x plus 3? It is 2. So e raised to power x is having derivative integral as ex and divided by the derivative. Number 17 is x upon e raised to power x square. See this x square. If you put it as t, then 2x dx is dt by dx, or 2x dx equal to dt. So the question changes to your, as you can, it is not necessary that you will multiply by 2 and divide by 2. If also you are just putting it back, so you can resubstitute means your x dx as half dt. That way also this 2 will come, right? This 2 will automatically come from here. Okay, so it becomes half of integral dt upon e raised to power t. Now e raised to power t in the denominator cannot be integrated, so take it as e raised to power minus t. Now what is the derivative integral of e raised to power minus t? It is e raised to power minus t, but don't forget to divide by d dt of minus t, that is minus 1. So that's why it will be minus half e raised to power t plus c. Now put back t as x square, and you will get the desired answer like this. Number 18, e raised to power tan inverse x upon 1 plus x square. Now see, the derivative of tan inverse x is 1 upon 1 plus x square. So you will get dx upon 1 plus x square as dt. So see, this is your dt, and this is your e raised to power t, whose integral is e raised to power t plus c. Put back your t as tan inverse x, and this is the answer. Now number 19 is a very good question, and see its connection with question number 20. Right? Number 20 is having your e's throughout distributed, whereas in number 19 e's are not everywhere. Right? So see, there is a strategy. I will make this question like this. How? What can I do is I will multiply and every term by e raised to power minus. So it becomes your e raised to power x minus e raised to power minus x, and in the bottom it is e raised to power x plus e raised to power minus x. Let's see. Okay, now put this as t. Why? Because its derivative is present in the numerator. Okay, see, what is the derivative is e raised to power x, and its derivative is minus e raised to power minus x, right? So it is present here, right? So arrangement means give me that e raised to power x minus e raised to power minus x dx equal to dt. So it becomes dt upon t, again log mod t plus c. Put back the value of t as this ex plus e raised to power minus x plus c, and this is the answer. Now in question number 20, what is happening here? No doubt the e's are distributed properly, but you need to just put this as t, right? So either you can get the idea of multiplying and dividing by 2, or if you don't get, then also it is okay, because see, when I'll put back, it becomes your e raised to power 2x into 2 minus this becomes minus times 2 e raised to power minus 2x dx and equal to dt, right? Like this. So 2 can be taken common, And if I have seen, if I have not multiplied and divided, means if it is like this also, so you know that I'll find out the value of this and this 2 will go downside here and it will become dt by 2, right? So automatically this 2 will come. So there is no need to learn or cram that you should multiply and divide by 2. Okay, so this after substitution the values, it becomes dt because this is complete dt. Okay, and this is half by t, so it is half log mod t. Now you put the value of t and you will get the answer. Now what is the integral of tan square? Whenever you have to integrate tan square, change it to secant square x minus 1. This is the only criteria of integrating tan square. Okay, so it becomes secant square 2x minus 3 minus 1. Now integral of secant square is tan x, tan 2x minus 3. But don't forget to divide by derivative of 2x minus 3. That is 2. So becomes half tan 2x minus 3. And integral of minus 1 is minus x plus c. Okay. Okay. And this is the reason. Now secant square 7 minus 4x, you know, integral of secant square x is tan x. So it will be definitely tan 7 minus 4x, but you have to divide by ddx of 7 minus 4x, that is minus 4. So this is the answer, plus c. Number 23 is sine inverse x upon root 1 minus x square. Now the derivative of sine inverse x, put it as t, it is 1 upon root 1 minus x square. Okay, so this becomes dt. So this is a simple question of t, this is t and this is complete dt. So t dt can be integrated as t square by 2 plus c, which is your half of, put the value of t as sine inverse x whole square plus c. Number 24, what you have to do is take 2 common from the denominator and put this as t. This is t. So when you will put it as t, you will find it becomes 2 cos x minus 3 sin x dx equal to dt, which is your denominator, this numerator. This question becomes half dt by t, which is half log mod t plus c, and we put this value to get this answer. Number 25 is 1 upon cos square x 1 minus tan x whole square. So change 1 upon cos square to secant square x. Okay, and put this 1 minus tan x equal to t. You will get minus secant square x dx equal to dt. So see, you can put secant square x dx as minus dt. Okay, so it becomes minus dt upon t square. Now again to integrate t square, take it to numerator, t raised to power minus 2. And use power rule, minus 2 plus 1 upon minus 2 plus 1 is minus t raised to power minus 1 upon minus 1 plus c. So it is 1 upon t plus c, that is 1 upon 1 minus tan x plus cos root x upon root x. Put this root x as t. Okay. Okay. Put root x as t. Remember this. Or x as t square. So dx is 2t dt. Change this question, changes to your 2 times cos t dt, which is 2 sin t plus c, and reput root x, and you will get this answer. Right? Then comes number 27, root sine 2x cos 2x. Whenever sine cos are together, it is suggested to put anyone, but you know that sine will give me plus cos in derivative. So it's better, I don't want to, extra negative signs, to put this sine 2x as t. So 2 cos 2x dx equal to dt. Right? So that means your cos 2x dx, this cos, either if I don't even remember to put multiply and divide by 2, that is also okay, right? Okay, so you can just put as here from here your cos 2x dx as dt by 2, so automatically it will come as half. Okay, it is root t dt, so it is half t raised to power half, so you can integrate by using power. Cos x upon root 1 plus sin x, put this 1 plus sin x as t. Cos x dx is dt, so it becomes dt by root t. Take this t to numerator as minus half, and then you can integrate. Cot x log sin x. Now remember, dear students, derivative of log sin x is cot x. So put log sin x as t. Now how will you differentiate it? As 1 upon sin x into d dx of sin x cos. So it is cot x dx is dt. So this question changes to integral. This cot x is this log sin x is your t. Okay, and cot x and dx all together will give you dt. So it is t dt, which is your t square by 2, and that is half log sin x whole square. Again sin x upon 1 plus cos x, put 1 plus cos x as t, and your question will be done. Change to t and you will integrate it. Next is sin x upon 1 plus cos x whole square. Here also put this 1 plus cos x as t. Change the question to t form and you will get the answer. So it's not giving you a problem, so that's why we did it quickly. Now this is the same question what we discussed in the question of that 1 upon 1 plus tan x, right? 1 upon 1 plus cot x. Same thing, change to sin cos. See from here. Multiply and divide by 2. Okay. So it becomes sin x plus sin x. Now introduce cos. So add and subtract cos. Break the two numerator, means together them, split the two terms. Sin x plus cos x upon sin x plus cos x. This will become 1, and this is your cos x minus sin x upon sin x plus cos x. Right? Now here put the denominator as t. See, it becomes f dash x upon fx. So same format is there. So this question can be integrated like this. And alternate proof is that, see, there is a formula. If it is an MCQ type of question, you can directly use f dash x upon fx is log mod fx plus c. And this is the same kind of question, 1 upon 1 minus tan x. Again the same thing. Change to sin and cos and operate the question accordingly. Root tan x upon sin x plus sin x into cos x. A very, very important question. Okay. Root tan x upon sin x cos x. So when sin x cos x are together in the denominator, it is suggested that try to change the question. In question tan x is there, try to bring secant. Okay, and here generally what we do, we divide numerator and denominator by the power of cos. Okay, so you know, to bring secant square I need at least cos square, so I am dividing and multiplying with cos square. See, divide and multiply by cos square. Okay, so it becomes your secant square here in the numerator, because 1 upon cos square will be secant square, and here it will become your, means if I'll divide this by cos square, what will happen? One cos will cancel it and you in the denominator will get tan x, right? And this secant square is taken to the numerator. Now put tan x as t, and the question changes to dt upon root t, which is t raised to power minus half dt, can be integrated like this. 1 plus log x upon x whole square. Okay. Now put this 1 plus log x as t. Okay. So this becomes t square dt, t cube by 3 plus c. So put back the value of t. Number 36 is very important. X plus 1, x plus log x whole square upon x. See this without square. Put it as t. When you will operate it is 1 plus 1 upon x dt by dx, or take LCM, you will find that this thing along with this is changed to dt. And the question simply changes to t square dt, which can be integrated as t cube by 3 plus c, and re-put t, you will get the answer. In number 37, tan inverse x raised to power 4. Put it as t. No need to multiply and divide by 4. It will automatically come. Right? Now what is the derivative of tan inverse x? It is 1 upon 1 plus x square. So here it is tan inverse x raised to power 4. So it will be 1 upon 1 plus x raised to power. X here is x4 square. So it is 1 upon, means it becomes, and ddx of, no doubt, ddx of x4 also, which is 4x cube. So that means my 4x cube divided by 1 plus x raised to power 8 dx is dt. Okay. So x cube, this will become dt by 4. So that way also you can introduce 4. Otherwise, if you know, then you can multiply, divide also. Okay. Is 1 upon 4 sin t dt, which is minus 1 by 4 cos t plus c, and re-put the value of t and you will get the answer. Choose the correct answer, right? So it is 10x raised to power 9 plus 10 raised to power x log e to the base 10, x raised to power 10 plus 10x. So see, here also put this as t. Now what is the derivative of x raised to power 10? It is 10x raised to power 9. What is the derivative of e raised to power x? It is ex log to the base e of a. It becomes 10 raised to power x log to the base e of 10 dx is dt. So this becomes your dt by t. It becomes log mod t plus a. Okay. Now put back the value of t and you'll get the answer. Right? And also it is simply the formula can be used like it is of the form of f dash x upon fx, right? Dx, which is your log mod x, log mod fx plus c. So you can see that my option number D for this question is correct. So this is all about method of substitution, right? Dear students, you need a lot of practice to understand that what is the proper substitution for a particular question. So take a lot of questions for drill so that you can understand this topic well. I hope whatever is taught is clear to you. Thank you so much.